Hello there, everybody. My name is Rod Deeritt. I'm the Director of Business Development at Delta Q Technologies. I'd like to welcome you to this session. I'd like to remind you that this session is being recorded, so it will be available on demand upon completion of this session. Just a note, if you have any questions during the session, there is a tab to the top right corner where you could actually voice your questions to any of the panelists or to myself. Everything's sent privately, and we can choose after and when appropriate to ask questions. With that said, I'd like to introduce our panel of guests related to the market trends in battery technology. I will have Brendan start off with introductions.
Sure, thanks. My name is Brendan Sauer, the Director of Product and Engineering here at Discover Battery. I guess a long history starting from software and electrical engineer, kind of working my way up through product management, and now leading that group, but a long history in both lead and lithium products.
Aaron Plew, Fullriver Battery, Director of Products, and also a long history. Started out in 2007, right out of college, and it's an exciting thing to be a part of. Absolutely.
Matthew Ely from US Battery. I'm the Manager of Product and Process Engineering, and I oversee the research and development for lead acid and lithium products.
Panos Prezes, Vice President of Business Development at now Beam Global. Formerly, we're just acquired. I was part of AllCell Technologies, and we have a proprietary passive thermal management and safety solution for lithium-ion batteries. I've spent my whole career in battery technology, engineering, product development, a little bit of R&D, business development most recently. Happy to be here.
Good morning, everybody. My name is Eric Stafl, President and founder of Stafl Systems. We're a provider of battery management systems and telematics. I've been involved in the battery industry ever since 2008, and been working on electric vehicles, stationary energy storage, electric aviation, a lot of interesting, particularly lithium applications. So happy to be here.
Great. Thank you for the introductions, gentlemen. Appreciate the collaboration and the support and your participation in this session, as well as the Charge by Delta Q program. To let everybody know, all the companies here are part of the Charge by Delta Q compatibility program with Delta Q. So any of their solutions have been fully validated, and it's solutions that work seamlessly and efficiently with our chargers. With that said, as electrification starts to proliferate, there's always a need to look at the battery as the first component to source, right? Whether it be lead acid or lithium ion, there's a home for all sorts, depending on the situation, depending on the requirements, the environment and whatnot. So what I wanted to do here in this session is really highlight some of the benefits on each of the solutions and really understand what technologies there are in the respective chemistries, so that the viewers, if you're looking at a battery solution in the future to use in your application, you have the knowledge base to be able to incorporate the right solution into your product. So we have a good mix, as you heard from the introductions. We have some lead acid supplier vendors, as well as lithium ion and battery management system supplier. So I guess let's start off with the lead acid side. Aaron and Matthew, I guess, Aaron first, as respect to lead acid, what's your most preferred chemistry? And I mean, it could be a multitude of chemistries, but I mean, what's the preferred one that Fullriver prioritizes?
Yeah, so our flagship product line is AGM. So we have AGM and gel. And so, yeah, that we, based on cost considerations, especially as of late, we used to be the expensive kids on the block, but welcome lithium, and so the cost sensitivity has gone down. And a lot of what has driven AGM in the past drives it today: sensitive environments, intense environments, vibration rich environments, and then accessibility. Can you get to the battery? Either A, because it's remote, or B, because it's buried in a vehicle. And then if it's maintenance free, you don't have the manpower consideration to maintain it. So those are kind of been our key points that we have enjoyed.
Great, great, good feedback. And Matthew, same question to you. I know that US Battery has been heavily into the flooded lead acid, but now has been introducing AGM as well. So I guess what propelled that transition or that introduction?
Well, essentially, people, like how Aaron mentioned, there's a few reasons why you would switch to AGM. The first one would be that they just really can't do the maintenance. Either they're elderly and they just don't have the manpower, or the batteries are just not as accessible. They're either in a remote location, up in the mountains or somewhere, or underneath a vehicle, hard to get to. So that's why people are tending to go to AGMs. There's also the benefit of lower internal resistance, so you're able to charge them much faster. And this is useful for solar applications as such, where you're limited to a certain amount of time where you can actually use sunlight, right? And so for a long time, flooded batteries have been our flagship battery, and they are still our dominant seller, but more and more you're seeing the AGM eat into that market.
Great, great. And I guess, is that like a lot of those benefits that Aaron and Matthew mentioned, are they something that is helping you to compete against the lithium market? I know that lithium price point wise may be a little bit higher. So maybe some of the benefits on AGM or gel versus lithium.
Well, I mean, the main one is the cost, essentially, the upfront cost, really. I mean, based on the data, lithium will last longer, and it is kind of a better bang for your buck, but it's that upfront cost that a lot of people have a hard time getting over. I mean, lithium can be 2 to 3 times as much as an AGM or flooded equivalent.
Yeah, so we approach this in 2 ways. First of all, I want to clarify, lithium is a very interesting technology. I think it has its place for sure. I think what lead offers is a diversity. I can take a GC2 AGM battery and I can put it in a golf cart. I can put it in a marine application where it's doing starting and running house lights. I can put it in an RV. I can put it in solar. And it's all one battery, one SKU to provide one solution. And it's readily available. You can go into any major city and find that GC2 all around the world. And it's not this, there's not the need for the specialization to deal with high rates of draw and things like that. So, yeah.
Yeah. So appreciate the feedback. Brendan, you're from Discover Battery, which actually has both solutions, right? So do you have any feedback on that?
Well, I was probably just going to agree with Aaron and Matthew there. Flooded is a great technology, but one of its drawbacks is it requires, proper charging and proper maintenance. Now, when you get in applications where that doesn't happen, all of a sudden it's prematurely failing. Not because it's a bad technology, but it's just not being used properly. Aaron, another great point. I think lead it's a bit more robust. You can get away with less system design. You can make more mistakes in your system design, and it becomes less apparent. And with lithium, there's a BMS that turns off. And it's only turning off when you're not charging correctly, or your loads or your charger isn't sized correctly. So you can get away with maybe not doing the best system design. But also, we are in a transition, and as you walk through that transition, you see a lot of equipment that has been designed and in production for 5-10 years, and all the controls and all the systems around the batteries were based on lead. So it becomes a very expensive proposition to actually move into lithium. It requires a bit of engineering, a lot of system knowledge. So if you've got a piece of equipment that was already designed for lead, you may just decide to redesign the entire chassis or platform specifically for lithium. But then you, from a business point of view, you get stuck in this kind of limbo where, because lithium is so expensive, you do have customers that maybe want to proceed with lead still. So going down the line, you may need to actually have two options. I want to be able to use that lead GC2, and I want to be able to use that lithium GC2 as well. But
Correct. So you brought up a good point as far as battery management, and we have Eric Stafl, which represents a battery management company, and we have Panos that represents a lithium-ion battery pack manufacturer, right? So I guess the challenges that Brendan had mentioned with relative to battery management and having to incorporate intelligence because of the battery management system versus just having a power source readily available that doesn't require as much system architecture design, right? I guess, what are the challenges you guys are seeing there, and has there been a big impact into the proliferation of lithium with respect to battery management?
Yeah, I'm happy to speak to that. Yeah, I think it's a great question, Rod. And Brandon, I appreciate the point, which is, yes, lithium is a more sophisticated technology in terms of understanding the system level implications of it. And so that's where, a sophisticated battery management system really is critical, because with lead acid, it's much more abuse tolerant. But then obviously it has cycle life issues. It obviously has energy density issues. Weight, some applications that's important, other applications it's not as important. But particularly if you're in an application like an electric vehicle where you really want to optimize range, you want to minimize weight, lithium really is the way to go. So in that situation, what you'd want to do is make sure that your system design can appropriately accommodate all the requirements for lithium ion, i.e., ensuring that there's never an overcharge scenario at a cell level, never an over discharge scenario, over temperature, under temperature. You really need to maintain lithium ion batteries in their ideal conditions for long life. And that's where BMS comes in. And I think one of the things that's really important for people in the industry who are just starting to look at this is, my recommendation would be careful in terms of trying to do your own BMS solution. It seems really simple at the surface. It's like, oh, we're just looking at cell voltages and reporting SOC. It's a piece of cake. Well, after doing this for 14 years, I'll tell you it's not. And we're still, optimizing algorithms. We're still improving things. And so, finding, in addition to, a battery cell provider, a really high quality, competent BMS provider is also critical in that piece for lithium. So that's what I think.
Great. And Panos, alongside with what Eric just said, as far as being able to upper limits, as well as know the inner workings of an actual BMS, I guess that introduces the factor of maintenance and safety, of which you're very familiar with because of your PCC phase change composite. So could you elaborate a little bit more on what Eric's stated, as well as maybe the safety aspect of what your company offers as well? You're on mute.
Sorry about that. Thank you. Sure, Rod. Thank you for that. What Eric and Brendan mentioned is true. There's these benefits of the better energy density. It's lighter. You have more utilization, more usable energy, better for high utilization applications, better life, et cetera, when you're using a lithium-ion battery. But you do have to integrate it a little more carefully than you would a lead acid solution. And I totally agree with what Eric said. You got to be really careful, especially if you're the product integrator of trying to do your own BMS. There's a lot of things you could just order a cheap BMS on Alibaba and weld it down to some cells, and it might work for a little while, but quite a risky proposition. There's a lot of more sophisticated BMSs that companies like Eric's provide off the shelf that we validate and use. We also have our own BMSs that we've designed in-house that are scalable and have some certifications to them that, that reliability is there. I also wanted our PCC solution also adds another layer of security there because it's a passive thermal solution. So if a bunch of things do go wrong, you've got this ability to absorb and distribute the heat that would come out of a failing cell in that worst case scenario. So, between BMS design, proper electrical current collector design, and integrating the right type of thermal solution, such as our PCC, that's the most robust approach that gives you a lithium solution that has all the benefits and doesn't have any of those downsides necessarily. If you take a simpler design approach in designing a lithium-ion battery. And as far as another comment on the system integration, you have lead acid replacement solutions out there all over the marketplace that are different types of lithium-ion chemistries, some NMC, a lot of LFP, and those are designed to be a drop-in replacement. And usually that BMS can handle whatever you're putting it into, making it equally robust as, if not more so in certain applications, certain environments than a lead acid solution. But all these do come with that upfront cost, and it makes sense if you amortize that over the life of it. You get that longer life. And it makes a lot of sense if it's in somewhere that's I can't remember if that was Brendan that mentioned that if it's tough to reach application, someone doesn't want to crawl into a tight space, or remote applications for backup power and things like that, hot environments, etc. A lot of competitive advantages there.
Yeah, well, the BMS came up, right? I'm in complete agreement with Eric. If someone came to me and said, "Hey, I'm going to start a BMS company," I'd caution them, "No, you don't want to go there." And it's a fun problem, and it's integrating lithium into applications is fun, but you need to start thinking a little bit differently. You've got concerns about just making sure the operating parameters of that equipment is within the specified range of the BMS, and that's the voltage, current, temperature, but that's not it. All of a sudden you need to start looking at other factors like inrush for loads. It's very hard for an electrical system to actually distinguish between a short circuit and inrush to a motor controller or a capacitive load. So, you go and plug an inverter in and you don't quite know, but it's pulling 5,000 amps when it turns on. Or oftentimes, if you're not using a motor controller, you might think, my turn on current's only 300-400 amps. But on closer inspection, it's 1,200 amps. So that doesn't lead you into just designing algorithms around the BMS, but it's also a fantastic topic to go research for anyone who's listening is water hammer. Very big issue with lithium is when that BMS opens, its internal relay current stops, and it'll have a massive voltage spike on the system. And if the system's not designed with protective measures inside the BMS and equipment, all of a sudden you start, you see electronics failing. So there's all kinds of very unique, specific things to consider that aren't just based on the algorithms of keeping the voltage and current and temperature in play. It's, you might go spend a year thinking about ESD, because as equipment's rolling down the carpet, it's arcing off a steel beam. Well, that's going right to the BMS as well. And before you know it, you're running down an ESD mitigation path. But a lot of vendors have been doing this for a long time. They've figured out all the wrinkles. So look for a good, healthy BMS vendor.
Got it. So it sounds like there's, albeit there's some advantages with going to lithium, there are also some challenges ahead. So I guess back to Aaron and Matthew, knowing that there's those challenges ahead, how do you approach, or how does your companies approach new opportunities, new applications, knowing that lithium is there, but there are the alternatives like AGN, gel, and flooded lead acid. Like how does that look? What's the primary benefits that you showcase as value add?
Absolutely. So obviously, the main appeal of lithium is cycle life and weight. With lead acid, we can't do anything about the weight necessarily, but we can increase cycle life. And we do have our Eagle series, which approximates the cycle life of many lithium chemistries now. And then the other side is safety and sustainability. So even LFP has issues with thermal runaway. It doesn't matter what, don't let anybody tell you different. It's the safest, but it still has issues. And then sustainability, the only closed loop of energy storage technology is lead acid. So that's important to us. I think that's a reality that at some point, whether we want to deal with it or not, we will be forced to deal with that whole giant pile of trash that we're going to be left with. Best case scenario, lithium is, panelists help me out here, 10-20% recyclable for on the high end. So if we shift everything over to lead acid, I'd like to do that. If we shift everything over to lithium overnight without solving these issues, so we really believe in that. That's actually a core conviction. We're not just here to sell all the batteries we can. I like lithium. We have our own machinations on lithium, but right now we are also convinced that if we're really concerned about this stuff, sustainability, that's our push.
Like the, go ahead.
Sorry, Matthew, do you want to add to that?
Oh, yeah. So I was basically what we've already kind of discussed. But also I really like the sustainability that you mentioned, Aaron, because that is definitely very key to me. And I feel like as the younger generation is starting to get into this as more as well, that it's becoming more of an issue that we do need to realize. And I think that once lithium does become more recyclable, then that will definitely be a game changer, and it'll be much more difficult for lead acid to compete with lithium. But I think at the same time, let the lead acid industry realizes this, and we are pushing into research and development for improving the cycle life or improving the active material utilization. I mean, right now we're sitting at essentially 40% active material utilization. If we were to get that up to 80%, you're essentially doubling the capacity within the same volume. So you're increasing the energy density. And those are the types of things we need to focus on, the research and development, in order to actually be able to compete with lithium going forward.
Got it. Anna, did you want to add? Brendan, you sound like you want to add as well.
It's a great topic, and I'm seeing some questions I was about to answer privately, but the recycling of lithium. So if you go back on a far enough timeline, there was no recycling for lead acid either. But it's a opportunity that the market must deal with. All the automotive manufacturers are rapidly moving to electric vehicles, so you're starting to see a lot of developments and investment into facilities that can recycle lithium, and they're working on their processes. So just as you take a lead acid battery and you can recapture the plastics, and you're recapturing chemical components for fertilizers and the lead, there's a lot to recover now from lithium. The metal components, even the individual chemicals in it, it's a little bit more costly. It's not a net, you can't net take cost out of it. So with a lead acid battery, there's a lot of intrinsic value with that spent battery, but it's coming because it has to come. There's a lot of very large automotive manufacturers and very large companies that, as a group, we have to deal with it. And I might argue one of the biggest problems right now is probably the ability to transport lithium batteries for recycle. It's not necessarily the inability to recycle it. I might have batteries here, but I'm struggling to actually get them to the recycling facility. So it's a problem or opportunity that's rapidly being worked on.
Got it. Appreciate the feedback. Panos, did you want to add?
Brendan, I was going to mostly echo what you just said. Probably the lead acid industry has been forced into recycling, decades ago. And I'm sure we all agree today it's the right thing to do. And the lithium ion industry, I believe, very recently is accelerated its catch up. Perhaps that wasn't true a year or two ago, but just from my time at Argonne, even a couple of years ago, I witnessed at the forefront of the development of a lot of these recycling technologies, and I've seen them deployed over the last few years. Brendan's also correct that because it's just deploying, it's not available in every state. So some of the challenges is if you're not right next to one of those facilities, you're a few states over, you have to look at that cost. And, but it's the right thing to do. It's the way the industry's heading in that trajectory. And all of these recycling technologies are accelerating. So I think it's by the time, the good news is these lithium batteries will let you, if we put them in the field today, for many of these applications, they're going to last 5, 7, 10 years. So we have a little bit of time to catch up there.
Good. Thank you for the feedback on that. Now, moving on to the next question or next topic, I know that we had mentioned that there were some challenges with integration of a lithium-ion battery via BMS. But I guess with that said, there are some advantages as well to having a BMS because albeit you have a lead acid battery that provides a power source, it's just a power source. With lithium-ion batteries via a battery management system, it now becomes an intelligent source. So Eric and Panos and maybe Brendan, if you guys want to expand upon that type of technology in terms of intelligence on the actual power source via the battery, and what the advantages are to the actual customer and or application.
Yeah, absolutely. Happy to speak to that. One of the things I want to highlight is, with the BMS and in a lithium battery, you have a much greater understanding of what's going on electrochemically within the system. And so what's nice about that is, in addition to all the benefits we mentioned, lighter weight, longer cycle life, lower internal resistance, typically, a lithium-ion battery, you can use a lot more of the available energy out of it. So with lead acid, you typically have to have a lot of safety margin in there in terms of 10, 20, 30% to make sure that, when you're on the golf cart, you're not left out on hole 16 or something. With lithium, you can bring it down, obviously with safety margins and everything that are part of the system level considerations, down to 2, 3, 1, 0% and still operate, albeit at a somewhat reduced capacity or power level. And the BMS allows you to do that. And one of the things that's also nice about a BMS is it gives you statistical information. So you can actually see, with data logging and things like that, how the battery is actually being used in the field and how it's aging and how it is aging compared to expectations. And one of the things that's really helpful about this is as you're looking at battery sizing and as you're looking at applications, you can say, okay, is it really necessary for this vehicle or this application to have a battery of this size? Or can we downsize it because only 1% of the use cases actually exceed this capacity anyway? There's a lot of flexibility there that a BMS and intelligence allows you to have. And I think one other point I just want to make is, we're going into an era where everything's connected via the Internet of Things. So we're talking about battery packs that will chirp up to the cloud and give you live status data of, their status charge, their usage, their temperature profiles. So as a fleet operator or even as a battery OEM, you can understand exactly what's going on with your energy storage system and continuously improve your product offering, your technology, your system sizing, such that it's more optimally tuned for your application. So it's a lot of exciting stuff happening in the next few years, I think. And, the BMS is a key part of that, in my opinion.
Right.
Yeah, I like to make a simple analogy, but one that may not resonate with some folks. But I view this as the transition from a carbureted engine to electronic fuel injection, and the transition from just mechanically driven engines to ones with ECUs. So it's not necessarily that there's a defined set of implementations you need to do. It just really opens up a world of possibilities. So you've got a component that has a lot of information about the entire system around it, and you can start to dynamically make active decisions. And as we're all battery manufacturers here, I'm sure we all could share or have a laugh. If there's ever a problem in a piece of equipment, it's usually the battery guy that gets ponied at first. It could be a charging issue, it could be a motor control issue, it could be anything. but it's a battery guy's fault typically. So we've all become very good at diagnosing systems. So like what Eric was saying, by having all that data there, it's allowing us to more quickly triage what are actually system issues, but present data that helps reinforce that. So whereas with lead acid or batteries that don't have data logging, you may present a good case, but you may have a tough time convincing someone of a problem. But now with that data, we can really step back and say, no, the battery didn't die prematurely. There was a massive, tear loss on it. You had some parasitic load, or nope, the charger didn't actually come on over the weekend, or no, it was 30 degrees below Celsius outside. You couldn't charge it. So it's really helping or offering the ability to educate users and equipment developers and designers on actually developing the system and how it's being used.
Brendan, I love that analogy with the carbureted versus the ECU. That's great. And it resonates so well because there's always going to be a place for lead acid, and it's going to really hold its corner in areas where maintenance is an easy thing, utilization is not that high or important. You're going to have that fun old 60s Mustang that you pull out every couple of weekends when the weather's perfect. Excellent. But nobody wants to go and tune a carburetor on the side of the road. No one, if anybody even remembers how to anymore. And no one wants to do scheduled maintenance every 2,000 miles like, used to be the case in the 70s and 80s on automobiles. And it's just in every possible parallel. That's such an excellent analogy. If you don't mind, I'm going to use that again. But back to the BMS topic, I think, all Eric's points spot on and as expected. I would just add that the future in some existing BMSs, the telematics that you guys mentioned, being able to, you can actually predict problems before they happen. So especially in fleet operations, or if it's something that's integrated at a system level, or even single user type of application, that predictive capability, solving problems before they happen, so they don't happen in the field or when you're X miles away from a service station or whatever, depending on this application that we're discussing. That is going to be, I think, really high value, and it's really just some cost. You already have it priced in. It's already the BMS cost is already amortized over that longer life, so you're going to get that competitive, especially in high utilization cases. It's a no-brainer. Something that we also add is a smart thermal tracking. So we have a phase change composite, being able to track this thermal state of that, so you can add a predictive layer to, okay, we know the temperature of the battery, we know how much power is capable based on the conditions of the cell, but we're also able to say, well, based on the thermal management that is available, we can also provide, perhaps additional power, leaving even smaller power margin or energy margin than you normally would in most of the ion batteries. So that's another big value add. Also enabling fast charging. I don't think that's really possible without a really smart BMS that understands what's going on at the cell level and thermal management level.
Great. So, like I said to begin with the session, both lead and lithium have their place in the market. There's needs and necessities that dictate why a customer would choose one or the other, right? They're definitely going to be needed in the marketplace. So I guess on to the next topic, in terms of both lead and lithium, and we'll go with lead first. What's the next evolution in technology for lead acid? Matthew or Aaron?
So continuing development, there's a lot of research investment going on still in lead acid technology, chasing that magic cycle life number. And so we have our own Eagle series that we're super happy with, and has made some great inroads. Actually, it's able to keep up. We're able to offer the same warranty as many of our lithium competitors in the light industrial space because of its reliability. It's just an impressive battery. And East Penn Deca has been doing their own research. There's been talk of what they call a wafer battery, and seems to have a lot of promise there as well. So yeah, there's continued development. The industry hasn't given up and tapped out and put up a white flag yet. So
Yeah. As Aaron said, we haven't given up. We won't go out without a fight. So, I mean, really, it comes down to, as he mentioned as well, increasing that cycle life and increasing the utilization of the active material, either through new designs or new additives that are coming to the market. And that's what I would expect from lead acid going forward.
Great, great. And then Brendan, on to you, since your company supports both. And maybe this is what transition.
I don't think lead's going away. I always joke, I'll be the first to say lead is dead, but lead is not dead. It'll probably outlive all of us here. It has its place in the market, and you may see more utilization of lithium as we go forward, but there's many cases where the business models, the cost profiles, the margin for businesses, it just doesn't make sense for lithium. So I see a lot of new equipment. Yes, it'll be transitioning to lithium. They'll likely still come with lead options, but there's also a lot of deployed equipment out there that's going to be using lead, and they'll be serviced and maintained for years and a decade to come. So, like I said, we like to tease the lead side of the organization, but lead's very much here and not in a hurry to disappear. So,
right. And I guess that's a good segue to your lithium side of the camp, right? So, like the evolution of lithium batteries as it pertains to the actual chemistries and different research and development happening on solid state, lithium sulfur, and maybe even different batteries outside of lithium. I don't know. Like, I'm not sure if your company is even looking into that.
Well, I guess we're always looking. Another kind of joke that doesn't come up every day, but often it's, in general, every day you hear about a new battery technology. 10 million cycles, it's going to last forever. There's always a lot of activity in research and development, but very few ever get commercialized. So we're always keen on hearing and participating in what's coming, but commercializing the technology is the next hurdle. So how can you actually produce it in such a way that you can widely deploy it? Then you get into new regulatory situations where, there might be some fantastic technology, but regulatory is rapidly developing and you're kind of in lockstep with that. So I'd say we like to not be on the bleeding edge of research and development, but we really like to catch on a technology it's starting its momentum down that commercialization path. And we bring a lot of benefits this whole group here, actually. You bring a lot of benefits to organizations who are at that point in time where they can start to adopt and deploy these new technologies. And that's the value our organization brings anyways. Not sure if that was a perfect answer, but
yeah, that's an honest answer, right? And that's all that attendees here could hope for, right? They want to learn, they want to engage and understand what's available, what the drawbacks and advantages are in each of the solutions, right? And they want to make the best calculated decision that works for their application and their opportunity. So appreciate it. Panos and Eric, maybe you could comment.
And Ron, if I could jump in there and just add a little bit, I think we've all seen those articles, and being in the battery industry, we're all forwarded from everybody. Hey, isn't this battery technology going to transform everything? That's not real. I've been looking at those articles for 14 years. Nothing's really panned out. What does pan out is incremental improvement and general technology progress. That occurs with all the different chemistries we're talking about. One thing I do want to highlight that I think could be useful for the listeners is, we've been talking about lead acid and lithium. The way I look at it is actually there's really three primary flavors of lithium that I think to the first order people should understand. So, there's lead acid for applications where you really want to focus on initial upfront cost. You want to focus on simplicity of the system, and it's always going to have its place. But then in lithium, there are basically three different cathode materials that I think are really worthwhile to understand. Number one is lithium NCM or NCA. That's a very high energy density lithium technology that's great for electric vehicles, great for electric aviation, where performance is really key. But that with great performance comes great responsibility. So safety, management, sophistication of your system design is critical. Down one tier in terms of energy density is lithium iron phosphate, LFP. It's a little bit more robust in terms of abuse tolerant, but like Aaron said, you absolutely can still get in trouble with LFP if you don't know what you're doing. So you still need a really competent system design, need an excellent BMS. And then one more tier down in terms of energy density is lithium titanate oxide, so LTO. And that's a technology that's a little bit more similar to the trade-offs of lead acid. It has some benefits to it, but it's lower energy density, higher power typically. So generally speaking, to first order, if you're looking at a solution for battery, a battery solution for your application, I would look at 4 different buckets of technology: lead, NCA, NCM, LFP, and LTO. So hopefully that's helpful.
And LCO in your mobile phones.
I'd agree with Eric there. Well said.
Yep. Well said, Eric.
Did you want to add to that?
Yes, I would. Thank you. Thank you, Rod. Thank you, Eric, for explaining those. To go back to the earlier comments regarding future technologies, I spent some time looking at those early TRL, far from being commercialized technologies, and working with at Argonne with the Department of Energy on some of those programs. And and I would see people would forward me these articles that somebody at the University of so-and-so developed something that lasts 100,000 cycles, weighs nothing, and is totally free. But they did it on a bench scale at this size, and they lit a little LED bulb. And the biggest challenge is going to be, how do they scale that up and commercialize it? And there's a lot of technologies that are part of the way there, and they show promise. And some of them were mentioned, whether it's lithium metal, lithium air, sodium sulfur. There's others that no need to mention now. But what I see is lithium ion dominating those markets that those would play in potentially in the future. Those really high energy dense, long life types of technologies. Lithium ion is going to dominate that for at least 5, if not 10 years. There's a lot of challenges in creating a stable, scalable, commercializable battery product out of those future technologies. So lithium is going to be around for a while, as will lead acid. I think we all agree both technologies have their place, and they're going to be around for a while. These energy dense, high utilization or high power applications, or where long life is important, are really, lithium ion is just, I think, is driving that clearly, and it's driving new markets of electrification, things that you could not consider electrifying even just a couple of years ago, whether it's aviation or aerospace applications, massive electric vehicle adoption. All these things wouldn't be possible with this high energy density, long life. And as those costs continue to drive down, though there's been a little pause on that cost dropping in the last year or so, the long-term trend is expected to continue. And I think we're going to see mass adoption there. Even probably, I don't know how many years exactly, but we're perhaps before lithium metal is widespread, lithium ion will be cost competitive even on an upfront basis with lead acid. Seen a lot of reasons to believe that, from industry analysts at the material level to scientists and analysts looking at the actual chemistries and technologies. I would say the last trend that I see coming is going to be safety is a more widespread consideration than ever. And I'm glad a couple of people mentioned it on this panel already, that LFP, though is considered, because it's less energy dense, it's going to be a little bit less volatile if things really go wrong, which, albeit rare, with the widespread adoption and of electrification of various marketplaces and all these vehicles. We're just hearing more and more of these stories. It's just the law of large numbers plays out that way. And as safety becomes more important, that I think you're going to see a big focus on certifications, ways to stop thermal runaway propagation, and that's something that we put a lot of R&D effort in, to enabling that with our technologies.
I was just going to say, to further reinforce that, even lead acid batteries have thermal runaway issues.
There you go. That's true. We forget that.
Great. Well,
I think
appreciate-
with just to poke in real quick, a dumb point, but a lot of this is going to be driven by the quality of the products that you purchase. So if there's a lot out there, a lot of really random things that are available to every consumer right now, and I think that's capitalism, but it's a little dangerous. So we definitely don't have all the engineering built in that we would like to see. So
Yeah, I want to second what Aaron's saying there is, looking just for the cheapest product off the shelf that ostensibly meets your requirements is a recipe for disaster. You need to understand what you're looking for in the life of it, from quality, from safety, from support. And I think one thing I will say is I do think the industry, or at least competent players in the industry, have really registered this fact. Remember the hoverboard scandal many years ago? You can get those duct taped cells out of China for super cheap, but anyone who's doing that, you're signing up for a world of hurt. It's much better to work with a competent battery BMS provider, charging provider even, who really knows what they're doing and can guide you correctly. Because unfortunately, there's a lot of misinformation in the battery industry, let's be honest, right? And it's very important to look through that and stress test your assumptions, build it up with real testing, real world validation data. Don't just trust a battery data sheet at face value. Let's all agree on that. Make sure that you understand who it's coming from, what's the third party validation, and is it really up to the task of what you're looking for? So I just want to underscore and agree with what Aaron's saying there.
Yeah, and I definitely agree with everything that you guys just said regarding the engineering and the development comes along with the solutions that are out there. And that really is a good summation of the Charge by Delta Q program, right? We've chosen you guys as partners because we've trusted your product. It's been validated amongst several iterations of different solutions that you guys have had in the marketplace, right? And it's something that's trustworthy and dependable, right? And that's really goes back to a core of Delta Q. It's reliability, dependability, the ruggedness solution that makes our name stand out in the marketplace. And we definitely appreciate having partners that share those same values. So thank you very much. I think we're coming towards the end of the session. I think we have a few more questions that are in queue. So let's start with Gil Van Kirchhoff. He asked on the evolution from lead acid to lithium, and it's not really an evolution right now because both of them still have a place in the market. He asked, is there a difference within that evolution in function of market it is applied to? Example, how does it differ between on-road and off-road vehicles? And any of the panelists, feel free to respond.
I think I'm not sure if I completely understand the question, but in general, the deployment or selection of batteries is always contextually based. What is your use case? What is the application? So if there's one technology or product that works very well on left stage, it may do a very bad job on right stage. So I think on-road, off-road, I might just hear vibrations. So yeah, you don't want to take a solar stationary battery and go and try and throw it in an over-road application, which we are starting to see, which is kind of scary. But I'll let the other guys speak.
Yeah, obviously, I'm thinking that he's leaning toward low speed versus high speed vehicles, and obviously there's a whole other set of considerations that go into engineering for a low speed scissor or boom lift pack and a Tesla or whatever on highway vehicle versus off highway, and that's going to be probably Eric and Panos's field right there.
Yeah, thanks, Aaron. Go ahead, Eric.
I just say right up your alley of the thermal management, probably of absolute primary concern. Whereas with low speed vehicles, it may not be, even top 3 or 4 considerations.
Yeah, that's you guys are spot on with a lot of the low speed applications we see and material handling applications. There's a safety aspect. There's still a human element around, or high value goods, et cetera. You don't want anything going wrong there. But there's a totally different safety designed for vibration, ingress protection, dust and moisture protection when you go to these off-road applications, or we have some extreme off-road applications. I don't think that's what the attendee meant with their question, but marine or off-road racing, dune buggy, sometimes we dabble in those kind of things, just to almost partial R&D test bed type of applications, but where thermal management is critical and different mechanical considerations and enclosure considerations have to be employed. So you could try to design the one size fits all, but then you might be stacking up costs that aren't necessary in a lot of the simpler applications.
So I guess another question, and maybe this is more towards Eric than anybody, but do you expect to see standardized interfaces between lithium-ion batteries and the vehicle, or battery and charger in the future?
Yes, absolutely. So basically, almost any BMS that you'll see in most industries now has a CAN communication interface. So that's a standard automotive bus that's leveraged, across industries right now. It's very robust, fault tolerant, and you can get a lot of data transfer that way. I would say this particular CAN protocols involved do depend on the industry and market you're talking about. So, for example, in off-road vehicles, you have SAE J1939, which is a kind of a standard on the CAN side that you would see BMSs support. But in general, each industry is still developing their standard. So, for example, on the drone market, there are some standardization efforts there. We're actually involved in some of them. So I would expect that to occur. But right now that simply hasn't happened. So basically each BMS has its own communication interface that the application controller would need to modify its code to adjust to. I would say we're probably about 5 years out, 10 years out until we see true standardization. But that is the trend that we're going to be moving in.
I really hope that day comes. I'd agree with that. A CAN interface is very prolific, but the protocol that is being used over CAN, every day I come across a new one. It's a bit of a challenge, but there are pockets of industries where you're starting to kind of converge on a standard.
Got it. There's a couple of questions, and I think you guys addressed it before. It's really the visibility of new technologies as a standard of next gen batteries. Any option for next gen batteries? Here, I'll just publish these because they're pretty much similar, and I think you guys have addressed it before.
Rod,
Maybe-
actually, I would add one thing that I just was reminded I didn't mention before, if you don't mind, regarding next gen
Sure.
technologies. We are seeing the lithium ion cell grow in size. The 18650 was the workhorse for a couple of decades. There's some variations that grew out of that, a little bit larger cylindrical cells, and now the 21700 looks like it's going to be dominating the next couple of years. And we see this 4680 that Tesla really spearheaded and pushed a couple of the major cell providers to start manufacturing. And it's all about getting that non-active material out, driving costs lower. But at the same time, it's opening these safety questions even further. You have higher energy density, plus more of that energy in one enclosure, one cylindrical can. So if something goes wrong, you need a lot more, you got to make sure you have a lot more smart materials around it, not just thermal management, but strong BMS and other enclosure design, et cetera, to make sure that can be managed safely. So, but I think we're going to see that trend play out in the next few years. Be able to hide on that.
Expand on that. So what we've seen is the core technology is always changing and getting better, but what's been consistent over the last few years, there's always a BMS. And I could see that not going away. So you've got a lot of vendors, and I would encourage vendors or equipment manufacturers who are thinking of getting into lithium, start now. Start your research, start your development, because even if that core cell technology changes, you're still going to be investing in that BMS communication interface. You're going to be investing in learning the technology. A lot of holdouts on the lead acid front, their entire platform is based on voltage triggers. and they just don't work with lithium. So those that have held out, maybe 3 or 4 or 5 years ago, now they're behind the mark. So even though that core cell technology may change, it's likely that you're going to have an ECU or a BMS around for a long time. So start getting after your firmware, your software integrations. Start now.
Sound advice.
Great feedback and very, very interactive section. I appreciate everyone's input because it does lend itself to our viewers and attendees here understanding the nuances and what necessities are to be able to integrate some of these solutions, whether it be lead acid or lithium ion, and the development that it's going to that there needs to be with the battery management systems going to lithium ion. On the attendees, I don't see any more questions in queue. If you have any more questions, we have a few minutes left. Definitely go to the top of the right screen, top right of your screen, and enter your questions. Let's wait a minute or so. Are there any closing remarks that any of you guys want to leave off with for the session?
No, I want to thank everyone. It's been a lot of fun. Next time, let's schedule this to be hosted in a pub, and it'll be a lot of fun.
Awesome.
Great advice. Yeah, I really enjoyed interacting with all of you. This was a fruitful discussion. Hope the audience sees it the same way.
I'm sure they did, because I valued the discussion that you guys had here. I mean, your technologies at times are competing, but there is a place, like I said, for all your technologies in the market. So thank you again. I appreciate the time and the support and the collaboration with Delta Q. And we look forward to working on solutions in the future. Thank you again.
Thanks, Rod. Thank you, everyone.
Thanks, guys. Great talking to you.
Bye.